Thank you for joining this PlatformCon 2024 Impact session, where I will discuss the impact of platform engineering in a hybrid world. My name is Drew Piland, and I am a Senior Product Marketing Manager at CloudBees. Over the next 15 minutes, we'll cover a few topics, starting with the hybrid landscape that affects all organizations. Next, we'll briefly provide an overview of platform engineering and its impact on the developer experience. And we will conclude the session with some practical guidance around common pitfalls and best practices to consider when adopting platform engineering. So when speaking with customers, a few business issues appear constantly. The first is around needing to decrease the time to market by boosting developer productivity. The next is around enhancing security posture across the software development lifecycle, whether from a security, governance, or compliance perspective. The next is around reducing costs while improving the overall service quality, which essentially is doing more with less through operational excellence. These issues themselves are not new, but they continue to be amplified as a result of the cloud transformation mandates that are being placed on organizations to modernize their software delivery infrastructure, which presents some additional complexity and nuance in achieving these goals. When dealing with cloud transformation, there are two fundamental truths we want to present. The first is that hybrid is a journey. According to Gartner, only 30% of enterprise workloads have moved to the cloud, and this number will not reach 50% until the year 2027. This means that while organizations continue to evaluate their cloud transformation strategy, they must ensure on-prem is included as part of that story for the foreseeable future. The next is that cloud applications are heterogeneous. They come in many forms, whether this is cloud native, lift and shift, or refactored. It is essential to understand the pros and cons of each of these approaches when evaluating how to modernize your software application portfolio. These facts present environmental complexity, which can be costly in many ways. Most notably, there's a direct impact on developer productivity. Recent stats have shown that developers only spend 32% of their time writing code. And if time spent writing code is how you measure developer productivity, then organizations have a lot to do to get this number higher. Succeeding in hybrid requires autonomy, letting teams select the right tool for the job while providing proper oversight. It's about continuing to support traditional applications for mission-critical work, but letting teams explore cloud-native applications to benefit from cloud efficiencies. By tying these things together through orchestration, you unlock centralized insights that are critical to maximizing developer time by spotting bottlenecks quicker, focusing on value-added tasks, and removing blockers. Platform engineering teams play a critical role in achieving these business outcomes. Platform engineering is an emerging discipline dedicated to reducing complexity and cognitive load for DevOps teams. So how does this differ from DevOps? Well, first, DevOps is not a role, but it is a way of working. It is a cultural movement designed for shared ownership and collaboration to achieve a common outcome. Platform engineering furthers DevOps by providing common services across the enterprise with abstractions to key infrastructure and tools that eliminate complexity and facilitate rapid adoption by the development team. Stated another way, platform engineering is about driving efficiencies within DevOps. And a recent study conducted by CloudBees showed that 94% of respondents agreed that platform engineering helps realize the benefits of DevOps. The goal of platform engineering is to optimize the developer experience and accelerate the delivery of customer value. Platform engineering teams treat your platform as a product and your internal teams as the customers. By dedicating themselves to improving developer experience, platform engineering teams allow DevOps and SRE personnel to focus on writing code instead of operational overhead, which results in happier developers. And Atlassian states that 76% of developers are happier when they have greater autonomy and flexibility into their tooling and are not forced into a specific tool set. Platform engineering teams often achieve this by building and operating self-service internal developer platforms, or IDPs. To succeed, they must optimize these systems for what their end users, the developers, ultimately want. And often this falls into four buckets. First, it's a means to rationalize their open source strategy, and to handle the bureaucracy that comes with licensing open source. Second is around codified service patterns or designs so that developers can choose from a toolbox or design patterns that architects have approved and generally linked to. Third is around golden paths or templates, which could relate to pipelines, pipeline flows, security scans, policies, you name it. And fourth is around the last mile of operation and supports, which involves documentation, runbooks, and potentially giving operations some visibility into the pipelines. So when dealing with the decision of whether to build or buy, it is important to evaluate the needs of your developers and your business. Start by asking yourself, is it a strategic enabler for your business? If the answer is yes, I would advocate building it. However, in most cases, organizations would say that tool chains and some software development lifecycle aspects are a means to an end. This is an area then where you should likely buy and assume those core capabilities via a vendor and then build your strategic enablers on top of that. Another consideration is your time frame for demonstrating value. And how are your resources set up to support this? While building offers ultimate flexibility, it creates a longer time to value and higher overhead. By buying a solution, the need to support, build, and manage it from scratch goes away. You also benefit from having a large development team and a potential community behind you. So now that we've defined platform engineering, I'd like to provide some context into the current state of it based on a recent study conducted by CloudBees. Platform engineering is gaining traction as 83% of organizations are currently in adoption mode. This supports Gartner's claims that by 2026, 80% of large software engineering organizations will establish platform engineering teams as internal providers of reusable services, components, and tools for application delivery. Since platform engineering is a newer discipline, we asked where this fits in the broader organizational structure. Cloud engineering and cloud centers of excellence were the most common response, and this makes sense. When you go back to the cloud transformation stats shared earlier, organizations realize that platform engineering is crucial to helping make the transition while keeping the developers first. Next up were the infrastructure teams that came in at 25% of the response, followed by development teams at 20%. Regardless of where they sit in the organization, it's essential to understand that their sole charter is around reducing complexity and cognitive load for the development teams. As we continue into our survey results, it should be no surprise that developer productivity is a critical adoption driver for platform engineering and is the primary metric used to measure its success. Second was around the management of CI/CD pipelines. And then you start to dive into other areas such as tool chain simplification, standardization across tools and processes, and the impact that all this has on reducing costs, enhancing security, and improving overall system resilience. With that in mind, let's shift from academic to more practical guidance that you can use. When looking at common pitfalls, the first one that comes up is around short-term planning, and this has a massive downstream effect. Platform engineering teams often start by supporting a single team ad hoc. This is not sustainable as it will result in each line of business ending up with its own silo of tools and processes. And over time, that's just additional technical debt that is building up. Questions that teams should consider earlier in the process include, how can these processes scale across the organization? How can we ensure flexibility in the tooling and APIs to avoid lock-in? How do we promote standardization for processes to create consistency? And what is our plan for implementing security along the way? Failure to plan leads into our second downfall, which is the most common, which is a lack of overall investment. Like any successful product, IDPs require sustained investment to be successful. This investment will grow over time and will eventually reach the C level for approvals. And if you plan for this, then you're in trouble. A major pitfall is the inability to show the strategic impact on the business. This is not because there isn't value, but because it has not been properly communicated. Platform engineering teams must never forget this and gather evidence of how they are helping to drive the business forward. The last pitfall is around adoption. And to steal a line from the classic baseball movie Field of Dreams, if you build it, he will come, isn't a given for platform engineering teams. Just because you build an IDP doesn't mean that developers will automatically flock to it. Developers are an opinionated group, and you must continuously demonstrate value to gain their adoption. This is a multifaceted issue because even if you gain their initial adoption, you'll then face another challenge. The reality is that the demand for platform engineering teams will often far outpace supply. Platform teams will evolve from team specific to a centralized function that comes with organizational demand. And this is where you get into potential funding challenges due to the finite investment levels. This results in platform teams sometimes struggling to keep up with developer demand, which could lead the developers to then explore other alternatives. Now that we've covered some of the common pitfalls, let's address best practices for how you can avoid them. The most successful companies have treated IDP investments like full product development. As with any product development initiative, you identify where your customers have pain or friction points. Then you consider abstractions to enable them through self-service or your platform team. The first best practice we have is to focus on small wins first and grow from there. Successful business outcomes are achieved by balancing people, processes, and technology. Platform engineering teams will have finite resources to address seemingly infinite requests. Prioritizing quick wins is of utmost importance, especially early on. The second best practice is around communicating your wins to gain adoption. Celebrate your wins early and expand as hypotheses are proven. Prove that you're receptive to developers by incorporating their feedback, demonstrating how you're making their work more fulfilling because happier developers are more likely to adopt your solution. Developer adoption is critical in the long run for securing executive buy-in to make your case for continued investments. To ensure these investments, you must quantify business impact of these wins. How much faster are teams releasing software? Is the quality more secure? And are you operating more efficiently? The third best practice is around keeping the focus developer-centric. Treat your internal developers like they are paying customers with plenty of other options should you not meet their expectations. Ensure their feedback gets incorporated in future cycles and make it extensible and flexible, often through the use of APIs. To summarize, cloud mandates have added complexity across people, processes, and technologies. Developers are instrumental in releasing features faster to market, but repetitive tasks continue to hamper their productivity. Platform engineering teams have been formed to help organizations realize the value of DevOps by reducing complexity and cognitive load for developers. Organizations commonly struggle due to short-term planning, limited investment, and a general lack of adoption. In order to avoid these, some best practices include focusing on small wins first, being sure to over-communicate these wins, and keeping the focus developer-centric. I recommend using a bottoms-up and top-down approach in this regard. Thank you very much for your attention in this session.